Hello everyone. So today we will cover practice discussion number 4. So the first task was quite simple, GCD LCM and average. So if we have a query with some number, so we will put like question mark A, then we will get this thing as an answer. So it's average of greatest common divisor and least common multiplier of a and x. So what is the solution? The solution is quite simple. So the first question will be always question to 1. And the answer will be x plus 1 divided by 2. Because GCD of x and 1 is 1. And LCM of x and 1 is x. So you've got this answer. So the answer, so x is either 2 times q or 2 times q minus 1. You need to remember that something will not work if your next question is just any of these numbers, in case if x is small number. So consider 1, 2, 3, 4 as separate cases. And then you can build the model. So for example, the next question can be question mark 2. And then you get, if it is x is even, so it's 2 times q, then the answer will be, so GCD is 2. And this is 2 times q divided by 2 will be q plus 1. And if it is an odd number, then you will get 1 plus 2 times this number. So it will be 4q minus 2 divided by 2. So it is 4q minus 1 divided by 2, or 2q minus 1. So as you see, the numbers are different, and now you can get what is the answer from that. Okay. Let's move on to the second question. So in the second question, we have a blue cell somewhere, and now we need to decide in which way we can put pink color so that the maximum number of pink cells will be reached. Okay, so let's say that this is the blue cell. So the question is where to place pink colored cells. So the answer is quite simple. This will be the first placement, this will be the second placement, and this will be the third placement, and this will be the fourth placement. So if k is greater or equal than 4, then there will be only one blue cell at the end, because everything else will be of pink color. So then the answer is just n times m minus 1. 1 because we have a blue cell. So this is a very easy case. And if k is less than 4, so if it is 1, this 1 can be placed at any place, but you need to calculate the area. So for example, if we put pink cell here, what we will have as a pink? This whole area will be pink, and this whole area will be blue. So it's quite easy to establish the area. It's just the coordinates you need to use and the sizes n and m. So for example, if we put our pink colored cell here above, then we will have x minus 1 times m pink cells. If we placed below, then we will have n minus x times m. So similarly, if we put something to the left, we will have y minus 1 times n, and if it's to the right, then it will be m minus y times n. Now you can compare all these four numbers, select the maximum, and output as it is. So similarly, if you have two pink cells to put, then the best way is to put them on opposite sides. So like here and here. Then the blue cells will be only along this line, which is pretty simple to calculate. It's just n. Or if we put them in other direction, we will have m. And that's all. So you just compare n and m, you select the smallest number, and you answer this number. So we will put n times m minus n times m minus m, and select the maximum number. However, there is a small case that you need to take into the consideration every time. So the blue cell might appear here, or even here. In this case, the location of the pink cell is not the opposite way. So in the bottom right position, the pink cells will be like that, and we'll have similar case to k equals to 4. Here we'll place one pink cell here, and another pink cell, well, we have only 3 cells above and 4 cells below of the blue cell, so we will place below to catch more. So then everything that blue will have is this part. So similarly for 3 and etc. So you just need to calculate all of those possibilities. Next, we have a hungry shark. So for hungry shark, we need to calculate how many salmon did we eat once the box number I is empty. So what is the solution? So the solution will be, so we need to calculate some sum. And we will write the sum as follows. So if we are at box number I, so the answer will be just summation from the first box to the box number I of numbers that are minimum of A at place J and A at place I. Which means if we already took everything from the box number J, then we cannot get like more. That's the whole thing. And then we need to sum from J's from I plus 1 to the final box. And here, similarly minimum, but of a different number. So the number is different because it's either a J or a I minus 1. Because we didn't reach those cells at this step. So we take AI salmon at this time from box I. So we didn't go to other boxes yet. So that's why they have been taken not more than AI minus 1. And the question is how to deal with that regarding that number n can be a huge number, and all other numbers will be like that. So to do that, you need something like fine-big tree, some data structure that can help you to sum all these numbers just based on the sum numbers that you've got already. So that's the whole idea. Next step is colorful paths. So this is quite simple task, but it requires you to run one algorithm with slight modification. So the algorithm will be BFS. And what is the modification? So in BFS, once we reached some node, so we reach this node, X, after that, we mark this node as visited. Now we do it with a different thing. So if we reach this node with color CI, then we mark this node with this color. And that's how it goes. Then when we construct all other paths, we construct them from all visited already nodes. So we cannot do edge with the same color. So it will be restricted. But if we reach the same X, node X, with a different color, then we remark this node X. So we put it into our queue of BFS again, but with a different marking, not with the color CJ now. No, if we reached it already with two colors, we will mark X is reachable with any color, because here we are asked for colorful path. So it can be 1, 2, 3. So for example, like that, path of length 3. So this is color 1. So next color is just not 1. Any color not equal to 1. So if we reached our node X with two colors, then we can use any edge going outside of X, because it's either of one of these colors or of any other color. So it doesn't matter. We can reach all other nodes after that. So it goes like that. So we will run BFS twice. No, not like you run it again. It's just you put visited nodes again into the queue. So for each node, it will be run at most twice. So the difficulty is not so high. And then you just list all the visited nodes. So regardless of the coloring. So they might be colored with the color CY, or they might be colored with this universal color, let's say -1. That means that it can be reached after that with any color. So it doesn't matter. Any of that will show that we can reach this node. And if reaching the visiting is 0, it means we didn't visit it with a colorful path, and we don't output this node. Next thing is GCD counting. So GCD counting, the interesting question. Here, we are asked to produce all the numbers of different subsequences of this array. So we are given an array of length n, and we have some positive integers that do not exceed m. So why are we given with m at the start? Because we need to create an array of length m to store all the numbers that we have here. Now, for each x, how many ways we can choose a non-empty subsequence, so such that the greatest common divisor of them, of the numbers in the subsequence, is equal to x. We will have this array of numbers 1, 2, so on, m. We need to output all of those answers to all of those numbers. So now the question is quite strange, but you don't need to go through all of those prime factorization and etc. to answer this question. Let's say we select number x here. So we need to fill this value. So the answer will be like we will go from the m to 1, not from 1 to m. So let's consider some arbitrary number x. Now, let's count how many numbers in this sequence, in the whole sequence, are divisible by x. So let's say we have a1, a2, etc., an. So now let's count how many numbers are divisible by x. So it means that how many ai such that x divides ai. So it's just how many numbers are here. Okay, we counted all of that. So then, how many subsequences are there? We can get any non-empty subset of this set. Any non-empty subset of this set will have GCD that is divisible by x, not equal to x, but divisible by x. So let's create like number fx, which will be equal to 2 to the power of cx and then minus 1. So minus 1 is to deduct the empty set, because empty set is out of our consideration. All subsequences must be, as declared, not empty. So that's why we subtract minus 1. Now, okay, so this is the number of all subsequences that has GCD divisible by x, but you don't know whether it is equal to x. So then we create something new. We'll create gx as equal to fx minus the sum of gy, where y is divisible by x. So we will say that all y are strictly larger than x. That's why when we fill this whole array, we go from the largest number to the smallest number. So we will go like that from right to left. So the first thing will be to fill for gm. And for gm, this whole thing will be equal to 0 because we don't have that. All of those will be equal to 0. And then you proceed to fill all other numbers until you reach 1. And then there you will have the rest of the numbers. Okay. Next question was water, which is a very simple question. So here we are given some limit. So we have a line of people that wants to get some water. So the first person wants 6 liters, the second person wants 4 liters, third person wants 5 liters of water. And then we have some limitations. So the first number is the number of people in the queue, and the second number is the limit of our bucket. Each bucket has a limit of so much water. So what do we do? Well, we just create a loop. If we try to fulfill the needs of the first person. And if we cannot do this, we increase our counter by 1. And then we put the number of how much water we have to C. And we proceed to next person. And we do it like that. So here the answer is 4, although we had to give like 3 buckets. Why is that? Because the last person will fill his bucket like with 1 liter of water, and then they will try to place a new bucket. That's why it's 4. So the last person will try to put a new bucket if the water was not enough for him. So that's the whole thing. It's an easy loop with some calculations. And the last question. So the last question is not very easy, but not as hard. So we are given some sequence of controls. Our robot is placed in the grid, and we are given some controls, and we are asked where the robot stops. So there are 2 cases. So if the robot attempts to move outside the grid, the instruction is invalid. So we stop. We don't perform this instruction. Now the question is how to deal with all of those things, because we have a lot of instructions, and also we have modifications of instructions. So, well, you will have to create something like tree, like fine with tree. So, for example, you have this sequence of movements. And for example, you know that this movement changes x to x plus 1 and doesn't change y. This movement changes y. So you can combine them and say that the whole change will be of x to plus 1, of y to plus 1. But you can do it for next 2. For example, this is minus 1 and this plus 1. So what you can do next is a tree. You can create what will happen to 4 instructions. So plus 1 minus 1 will be 0 to x, plus 1 will be plus 2 to y, and so on. So what you need to remember here, you need to have the maximum and minimum offset. So starting with this, let's say some x and y, what was the maximum x along all of that? What was the maximum y along all of that? And also what was the minimum? Because here we have this invalid instruction. So if we reach some invalid instruction, we can check it just what was the maximum offset. If it is like a lot, then we go down on the tree and we see where exactly we had that. So we skip that instruction. But nevertheless, it will save a lot of time for us. And the modification experiment, we will have to modify our tree. So once you want to calculate something, you will go just down the tree and you will find a lot of things. So that's the whole idea how you can deal with this task. I hope it helped, and see you next time.